Well, a very good evening and thanks for clicking on to the very first Vogans Long Range Outlook edition of the video for today. It is the 20th of September, and if you haven't already, I did write an article last night which, well, it was the first article talking about the upcoming winter of 2020-21 and some of the ideas that I've already got at this moment in time. Now, in just recent days, some pretty significant news came out of NASA declaring that solar cycle 25 has begun. Now, if you look back to 2009-10, of course, if you followed me over the last 10 years or so, I have always believed that 2009-10's winter was driven by the solar minimum. It was the weakest solar cycle in somewhat of 200 years, and 11 years on, and we have now reached another solar cycle. And as expected, this solar cycle, like solar cycle 23, was very, very quiet indeed. The reason why I say that I've always believed that the 09-10 winter was driven by the low solar cycle is because there's aspects going on at the moment globally, both in terms of ocean temperature, atmospheric temperature, the behaviour in the wake of the recent 17-18 Super El Nino has somewhat made me question a little bit about the role that the sun has. Now, if you read last night's article, I did say that some scientists would say that the sun is naturally going to be a driving mechanism to the Earth's climate, but some would say that it's the primary driver to the Earth's climatic system. Yet there's other scientists out there, and I do concede where they're coming from, that there is a minimal impact in terms of the short scale. You might be talking about the influence of the sun perhaps in a longer period of time than initially thought. So even though we've reached the solar minimum back in December of 2019, there is aspects of this minimum that is going to be very interesting to watch as we go through not only the upcoming winter season, but over the next couple of winter seasons, because of course there's a lag. The solar cycle 23 ended and 24 began in 2008. So there was about roughly a 12-month lag, where we've seen, of course, the worst winter here in the UK and across much of the hemisphere since 1978-79. So the Earth is naturally a lot warmer now than it was 10 years ago, both in oceans and atmosphere. I don't think anybody really can dispute that, based on the fact that if you look here at the September sea surface temperatures globally, yeah, there's a fair amount of warmth globally, and especially up in the Arctic region, of course. You've got cold water in the North Pacific, you've got cold water somewhat in at least the middle portion of the Mid-Atlantic, the North Atlantic, cooler waters underneath, and of course these are the sea surface temperatures at this moment in time here. A lot more warmth in the North Pacific. And of course, instead of having a developing El Nino, we've got a developing La Nina. And what I'm hoping for, folks, is that this La Nina will drive down Earth's temperature globally, because it has continued to rise despite coming off that Super El Nino, which of course you would expect the Earth to warm up. It seems to be that there's been less and less cooling in the wake of these El Ninos. These El Ninos, of course, warm water in the eastern equatorial Pacific, essentially drives the Earth's temperature up. But we haven't seen that coming back down again. And it looks very like there's going to be a pretty strong La Nina developing at this moment in time that will have influence on not just the upcoming winter season across the hemisphere, but also hopefully it will start to drive down that temperature here. But there's aspects that I'm looking at here, folks. The solar minimum, there is research being done that suggests that when you've got a solar minimum, there is increased chance of high latitude blocking. So high pressure up in the high latitudes typically means that you've got colder air in the mid-latitude pattern here. Now, recent years, of course, we've had more of a positive North Atlantic oscillation, which of course has continued to keep the westerly winds into Western Europe here. So generally speaking, the winters overall, really since 2009-10, and even of course really since we had the changeover in 2010, where of course we had the coldest December for the British Isles in 100 years in 2010. Then the rest of that winter really was a no-show, and really generally since that, the grand scheme of things, maybe about 8 out of 10 winters has generally been warm and wet. And it's going to be interesting to see the response to both the solar minimum but also the global sea surface temperatures, the response of the La Nina here, and whether we can see high latitude blocking. Warm water, by the way, up over the northern half of the earth tends to support high latitude blocking. If you've got a big October snow cover over Siberia, which I question this theory, to be honest with you, because I've seen less snow cover over the Eurasian continent, and we've still had significant block and high pressure up over Siberia, which has delivered cold weather. I've seen years that we've had big snow cover over Siberia, and we've just simply not had the blocking. So I'm very skeptical when it comes to the theory that you get more snow cover over Siberia, over Eurasia, you enhance the blocking over the top. The Arctic oscillation basically is in negative mode. I believe we are overdue a firmly negative Arctic oscillation and North Atlantic oscillation winter, and there is a possibility here, folks, that we've got several things in place that could enhance that possibility. Now, of course, last year we had a super strong polar vortex. We had, of course, very warm water here over and to the east of Australia and over the continent, the maritime continent, and that was fueling thunderstorms over the West Equatorial Pacific, which in a sense was leading to a stronger area of low pressure, not high pressure, but low pressure further north up into the Aleutian area of the world here. So the Bering Sea around Alaska, we had more of a stronger Pacific jet stream in response to the Madden-Julian oscillation being driven by these warm waters, fueling thunderstorms. And of course that had a ripple effect not only across North America, but of course across the Atlantic and Europe as well. It was a very powerful westerly airflow across the northern hemisphere last year. Now, there is model indication that there is a somewhat weaker westerly flow developing with the polar vortex. So in other words, the polar vortex was that strong last year. There was no build-up of high pressure that was going to disrupt that polar vortex. That thing ruled the roost last year and kept the cold air locked up over the Arctic region. But I think this year, with a slower wind circling the polar vortex, a general slower motion at jet stream level means that with high pressure potentially developing here, because if you've got a very strong high jet stream, you typically don't get the blocking to develop, because these areas of high pressure that develop and lift northwards are basically getting ripped apart by a strong zonal jet stream, and that's exactly what we got last year. But I do think that we are going to see something a bit different this year. Whether we're going to get a big winter or not, I'm not sure, but I certainly see slower westerly winds, the potential for the QBO, the quasi-biennial oscillation, to turn more easterly, and I do think there is model indication that we could be talking about more blocking areas of high pressure. Now, the key is going to be, folks, for Britain and western parts of Europe, yes, you can get a negative Arctic oscillation, but if you don't get a negative North Atlantic oscillation, you tend to struggle to get that perfect setup where you get the nice blocking area of high pressure, not only over Greenland, but over the North Atlantic, shuts down the westerlies, shuts down the Atlantic flow, and basically reverses that upper level wind flow pattern from west to east. That we have just simply not really seen that much since the December 2010, and of course we did see it, of course, with the beast from the east a few Marches ago. But it's going to be interesting here to see what exactly take place. This warm water over the North Pacific is a concern. I would want to see that cooling significantly, because typically when you've got very warm water over the North Pacific, you increase the thermal gradient over North America. That, in a sense, quite often relates downstream to a stronger North Atlantic jet stream and a positive NAO. So I'm kind of hoping to see that cool off somewhat. But it's going to be very interesting. Certainly over the next couple of days here, folks, we are going to start to see the NAO go negative. And I hope this is a sign of things to come, by the way, as we go towards the winter season here. A weaker polar vortex has more chance of being disrupted by areas of high pressure. Now, if you also look back at these current sea surface temperatures as well, you've not got just the same amount of warm water here as you did over the Western Pacific, but you don't want to see that, because that typically would drive more of a inconducive Madden-Julian oscillation, if you will, which would have a detrimental effect further downstream here. So looking at the CFSV2, this is for October here, and upcoming month, of course, not far away. Incredible how quickly we're rattling through this year. But you notice here, there's a bit of a positive here just to the south of Greenland. We've got a trough extending from Iceland down to Scotland here, so that is not necessarily the coldest looking pattern, if you ask me. That does look as if we're going to continue to see more Atlantic weather with low pressure to the north of the UK. But in saying that, we do have stronger than normal heights extending from Newfoundland up to Canada, or up to Greenland, and therefore that would indicate to me that we don't have a particularly strong jet stream here at this time, and that would be a positive indeed in terms of blocking and cold weather. But as we continue to skip through, this is into the month of November here, folks, and you can see here that again, nothing necessarily to write home about. We've got a trough over Alaska, we've got a strong mid-Pacific ridge. That would indicate a fairly strong zonal jet stream here. So November still looks as if we're going to continue to see a relatively Atlantic-driven pattern. But things start to get interesting when we go from November into December, because notice here that we start to see a North Atlantic ridge extending into Greenland. So you're cutting off the Atlantic. You've got a trough of low pressure here. Very La Nina like this, by the way, where you've got the trough extending from Alaska all the way into the Northern Rockies here. Strong positive over the Pacific. But notice here that we've got a ridge of high pressure, a blocking ridge to the west of the British Isles, and a trough over Europe here. This would be a sign that we could have somewhat of a colder month. And La Ninas, by the way, sometimes can have a kind of front-loaded winter, where you get the worst of the winter perhaps say before Christmas, or generally between the end of November and perhaps the beginning of January, and then things just shut down again. So it's going to be very interesting to watch here. I do think we've got a better chance at seeing blocking and potentially a stratospheric warming event perhaps early on this winter, based on all the different driving mechanisms I can see. And this is by the time we skip out to January, we've got a trough generally to the west and to the north of the British Isles here. Again, not the coldest of looking patterns, but notice that we are seeing a ridge of high pressure extend from the Bering Sea up over the top of the pole and down over Greenland here. So this here, folks, by the way, if this continued to show up here, this would indicate more of a negative Arctic oscillation, more of a trough, perhaps over the British Isles, and a colder weather pattern. The moral of the story is, folks, we do not, at least at this moment in time, The CFSV2 does not have a big blue area of low pressure over the Arctic like it did last year. It's got more positive over the top, and of course these troughs over North America and over Europe here. So this is a positive sign. This is a different sign to what we've seen back around this time last year. So it's just thoughts at this moment in time. Very early days still. Still want to see how October pans out in terms of weather. See how the models continue to read what's going on both in the oceans and the atmosphere as we change from summer towards winter season. And that's it for today. Hope you have a great day, and I'll be back in the next few days with more. Bye for now.